This video is on graphing radical functions. We're going to look at the general form of a radical function. It's a function that can be written in the form f of x equals a nth root of x minus h plus k, where a is not equal to 0. This is very similar to quadratics when you have a times x minus h squared plus k. This is just instead a radical form. So we still have our a, h, and k. So function notation is still very important here. We have the a f of x minus h plus k. For even values of n, that means an nth root, so our even values like the square root, fourth root, sixth root. The domain of a radical function is the real numbers that start at h and go to positive infinity. This is in the situation where our x value right here, there is a positive in front of our x value. If there is a negative in front of our x value, which is something you'll see in a higher math course, it will change. But as long as your x value is positive, you will be able to have a positive infinity. For odd values of n, so if we're dealing with the cubed root of anything, or the fifth root, the domain of a radical function is the real numbers where negative infinity to positive infinity. That means that our graph will go forever left and forever right. Now, a radical function is the inverse of a square. So in quadratics, we had a parabola that opened up and it went left and right forever, so our domain was left and right, negative infinity to positive infinity. But this time, a radical function will graph only half of it, basically. So that means that anything that will make the square root negative on the inside is bad, because we cannot take the square root of a negative without getting an error or an imaginary solution. So that means that is why we want to know what our h value is. So we still focus on our a, h, and k. So on here, on this problem right here, we have our a value is equal to 3. Our h value is going to be, again, we want to figure out what value would make this 0. So 2 minus 2 is what gives us 0. So our h value is actually a positive 2. And our k value is equal to that positive 6. So if we're talking about our domain and range here, because this is a square root, our domain is going to go from our h value up to positive infinity. So our domain is our closed bracket of 2, comma, positive infinity, because it's going to go, it will go to the right forever. Then our range, for our range, because we only have part of our, basically a quadratic, which is sideways, because it's going to be an inverse of a square, we only have the top half or the bottom half. So again, we still focus on, since it's a square root, we focus on, do we have the positive or negative value? This is a positive a value. That means it's not reflected. That means we're going to have a positive infinity for our range. And our k value still tells us where it starts from. So our range is 6, comma, infinity. It's very similar to going back to quadratics. Now, as we said earlier, for the odd values, we would have the domain is negative infinity to infinity. And in this case, a cube root will be a different type of shape, which the range will also be negative infinity to infinity. It's very similar to a linear type of function, which has an odd exponent as well. So on this one, our a value is equal to a positive 5. Our h value is equal to a negative 4 plus 4 will give us 0. So the value would be a negative 4. And then our k value is equal to a negative 2. But since this is a cubed root, our domain is going to be negative infinity to positive infinity. And our range will also be from negative infinity to positive infinity. That's the type of function it is. Don't forget, we'll also want to know if a is positive or a is negative. In this case, they're both positive, so it did not reflect. So the reason we want to know that is, again, going back to our function notation. The parent function, which is, if we're dealing with a square root, it's just y equals square root of x. But for just any type of radical, it's y equals the nth root of x. And it would be the a, but it's supposed to be a 1 here. So going back to just parent functions, how are these changed from that parent function? The reflection over the x-axis is still, if your a value is negative, it still reflects over the x-axis. And then if you have a value of a that is not 1, it's either going to be a vertical stretch or a vertical compress. So it still goes back to the same information we've seen before on quadratics. So if a is bigger than 1, it's still a vertical stretch, and if a is smaller than 1, then but still bigger than 0, it's going to be a vertical compress. Because remember, the negative affects the reflection, not the compress. But then your translation, it's still moving left and right based off of your h value, and then it's still moving up and down based off of your k value. So you're still dealing with the a f of x minus h parentheses plus k. This is still function notation. It's just this time we're dealing with a radical instead of a square. Okay, so we're still dealing with that same type of function notation.